In this video, we're going to be talking about reasoning with slope fields. So if there's an FRQ with a slope field, you have to generate the whole thing yourself. However, in multiple choice questions, you can't really have to generate a slope field for a multiple choice question. So sometimes you just have to answer questions about a slope field that's given to you. So a slope field gives us a picture of what a possible solution to a differential equation could look like all these little lines. You think about following them for the slope and the tangent lines of your original graph. And something that might happen, you might be given an initial condition, so it's a value we know is on the solution, and then we use the slope field to kind of follow what it should look like from there. So here's an example. We have this slope field, and we have these different initial conditions. So let's do the first one in blue. So y of 0 equals 1. So when I put in 0 for x, I get 1 for my answer. And 1 is 1, 2, 3, 4, like 5 of these tick marks. Let's just say 1 is there. So that's the point 0, 1. And I just follow my slope line. So as I follow my line, I have got a steeper line here, and then a less steep line, and then these ones kind of tell me to just go to the right. I would look like that. And then going backwards to the left, I'm going against the arrows. These arrows are steeper and steeper and steeper. So to me, that's what it would look like if I had y equals 0, 1 on my differential equation. So I knew this point on it, my answer would have to look like that. I would about 0, 0. Well, on 0, 0, this line just tells me to go to the right. That line tells me to go to the right, and I keep going to the right. If I go backwards, I'm going against the grain, but all the lines are telling me to go straight. That would be my answer if 0, 0 I knew was on my solution. And what if I knew 0, negative 1 was on my solution? 0, negative 1 is there. I follow this line, and then I follow the next lines are a little less steep, and then I get to here, and these lines are less steep, and they tell me to start going to the left, and I go against the grain that way. All right, so you can see how knowing an initial condition changes what my answer may look like. Right, here's another slope field, some more initial conditions. So 0, 3, let's do this one in blue. 0, 3 is here. Right away, I have a pretty steep line going up and more steep lines going up. And I go backwards, I kind of hit this bar of things that tell me just to go straight. So I have something that looks like that. What about 0, 1? 0, 1's here. So going to the right, this arrow is pointing me down to these flat ones, and I'm going to flatten out there. And going backwards, this arrow would point me this way, and then I hit all these flat ones, and it looks something like that. It shouldn't go back down, but that's kind of what happened as I was drawing it. And lastly, 0, negative 1 here. This line pushes me straight into these flat ones, and going backwards I just get these really big values like that. So again, the initial condition, as long as I kind of follow along with the way the arrows are pointing me, and then backwards as I go to the left, I'll be able to figure out a general shape of my differential equation. All right, so now look at some ways this might come up on the AP exam. So here we have a slope field. Which of the following statements about the solution of y equals f of x to the differential equation is true? So if I have 1, negative 1 on my solution, 1, negative 1, it's concave down on the interval. So if I go this way, it looks like it's pointing me this way. If I go this way, it looks like it's pointing me this way. All right, that looks like it's always concave down. All right, so I think A is right, which means it's not false, so this is not the right answer. B, if I have negative 1, 1 on my answer, well, let's see, as I go to the right, these lines are all sending me higher. As I go to the left, these lines are kind of pushing me that way. Is this graph concave up from negative 1 to 0? Yeah, it looks like it's concave up, so that one also looks like it's right. And we get lucky, the last two both have to do with 0, 0. So as I have 0, 0, as I go to the left, these lines are pushing me slightly up, and I go like that. And as I go to the right, these lines are pushing me down, and I go like that. So is it concave up from negative 1 to 1? No, because it switches to concave down there. Does it have a point of inflection? Yeah, it kind of switches from being concave up, concave down. So D is right, which means the actual answer to the question is C, because that's the one that's actually false. I mean, see how this is asking you a lot of things. One, do you know how to create graphs from a slope field? Do you know what concave up, concave down, point of inflection is? So they're asking you a lot of things in this one question. Here's another one. The slope field is given to you. They give you the initial condition. Which of these equations could be the graph? So I'm going to have to graph it first. I know 0, 0 is on my graph. As I go to the left, this line points me up, and these lines point me up, and I have that kind of asymptote that way. And as I go to the right, these lines point me up, and I have something that looks like that. So how can I determine what my graph is? I had to look at these and figure out which of these could look something like this graph. Exponentials look like this or like that. They level off on one side. This one definitely doesn't level off, so that's not right. 1 over x squared minus 1. X squared minus 1 is x minus 1 times x plus 1. This graph would have asymptotes at 1 and negative 1. We do have an asymptote at negative 1, this line going up, but at 1, we're kind of just doing a normal thing, so this one's out. X squared over 1 plus x, this one would have an asymptote at negative 1, and some other stuff would happen, so this one's still in the running. The tangent over 1 plus x, this one also has an asymptote at negative 1, but tangent also has a crazy amount. Tangent looks like this when you graph it. A crazy amount of asymptotes. So this one can't be a tangent on the top, so my answer is C. It has the asymptote in the right place, and nothing else weird is happening. This could be my graph. All right, exact same type of question. Again, you could pause it and try to figure it out on your own. I now have the initial condition 0, 0. Going to the right, all these point me down to this kind of level there. Going to the left, they point me up that direction. All right, so which of these could be the graph? X squared minus x is a polynomial. They never level off, so that's wrong. Sine of x is a wave. It's definitely not a wave. And then which one of these two? E to the negative x or e to the negative x squared? Which one could this possibly be? This is one just helpful to note. E to the negative x squared, going both directions, you get these negative. E to the negative x squared looks like this with a little hump in the middle. This is not a hump. And exponentials either look like this, where they go big on one side and small on the other, or like that. And that's exactly what this looks like. This looks exactly like that shape, so C is the right answer. All right, so just kind of knowing generally what your functions are and what their graphs might look like is going to help you with these types of problems. All right, so quick summary. All right, start with the initial condition on your slope. So put that dot. You just kind of follow the slope lines as you create your graph. I pay particular attention to anything that's like a straight line up and down, because that's going to give you an asymptote, or a straight line left and right. That's also going to give you kind of a horizontal asymptote. And you're often going to be asked what the equation of the final answer is going to be. So just make sure you're comfortable with knowing what exponentials look like, knowing what your trig functions look like, knowing polynomials don't level off, rationals have asymptotes, that type of stuff.